Morning students. In the today's class, we are going to start with a new chapter, like states of matter. States of. Okay. So students, this whole chapter covers 8 marks. Okay. So in that, one question for 1 mark. It is question number 5. And one question for 2 marks. That is question number 15. And another question is for 5 marks, that is question number 28. Always. The question number 5 is from states of matter in the first main. And then the second main, the question number 14 is from states of matter, that is 2 marks question. And in 5 marks question, part A, B, C, D is there in your paper, you know that. Part A is only 1 marks question, part B 2 marks, part C 3 marks, part 4 and D are 5 marks questions. In that, part 4 is purely based on that physical chemistry only. Okay? And the last part is only organic chemistry. Understand? So this is states of matter, and this much of marks weightage it has in the annual examination. Okay, students? So in this, what you are going to study is, what are you are going to study in the states of matter is, first one, how the matter is classified, especially the physical classification of matter. Physical classification is they classified as solids, liquid as well as gases. Okay, here in this chapter you are going to discuss about only liquid and solid state. Later in class 12, okay, second PUC, you are going to discuss about the solid state of the substances. States of matter in that solid we will study in the next class, next year. Okay, in for this only we will study liquid state as well as gaseous state. So students, how the liquid state varies? So it has different properties. Like to explain the properties of the gases, so many laws are there. One is Boyle's law is there, Charles law is there, ideal gas equation is there, Avogadro's law. So all the Gay-Lussac's law, all those laws explains the properties of the gases in the atmosphere or in the solution or in the solvent, whatever it is. Wherever the gas present, what happens? And affect the factors which affects the gaseous state. It may be a temperature, pressure, like that. If gaseous atoms are there, if we increase temperature, liquid is there. If we increase temperature, it will changes to gas. If gases are there, if we apply pressure, they come closer to each other, then they form liquid or they liquefy. Understand? So this is the factors affecting the states of the matter. That is we are going to study in this chapter. Okay. First, the gaseous states, their behaviors. Okay. How gases behaves if they are with the gas, if they are with the solution, solvent, liquid, solid, like that. Understand? And the forces of attraction between the gases and the liquids. If any atom should form, means it should possess some amount of attractive force. Then only they will stay together. Understand? So that forces, which type of forces are there? So in gases, what forces are there? Whether they are weak or strong. So those we are going to study in this chapter. And then later, if you consider that liquids means, in that liquids we are going to study surface tension, viscosity and vapor pressure. Okay, so this is all the things we are going to cover in the states of matter. Based on this, problems is also there that depends upon the gas laws. Then as the problem based on Boyle's law, Charles law, and also our ideal gas equation. Okay, and later I will do problems, then you will understand this. So now we'll start with the states of matter. So matter means it is a substance which has mass and occupies some space. Correct? So matter is a substance which has its mass and occupies some space in the some space. Understand? That is called matter. So the matter here, as I told you, here we are only considering the physical classification. So in the chemical classification, they classified as elements, compounds, heterogeneous, homogeneous. We don't bother with it. Okay. So just we'll discuss the physical classification. They are classified as what? Yeah, matter is there. So it is classified as solid, liquid, as well as gas. This is the different states: solid state, liquid state, and as well as gaseous state. So students, I will write the diagram here first. This is the arrangement of atoms in solid. Correct? So if we consider liquid, this is the arrangement of atoms in liquid. If we consider gas, this is the arrangement of the atoms. So students, as we compare to solid, liquid and gases, don't think there is a less number of atoms. It is simply like the distance between the two atoms is very less here. Here comparatively more. Here very large. Okay, distance between the atoms. So here in solids they are tightly bounded. They are tightly bounded. So in liquid somewhat loosely bounded. So here very loosely bounded. Okay, students, remember here two atoms are adjacent to each other. Means the nucleus of the both atoms are very near. Correct? Means the force of attraction between the nucleus and the electron of the other atom is very high. Understand? If distance is less, then attraction is more. That means force is more. Understand? So here they have less or small intermolecular distance. They have small intermolecular distance. But at the same time, they have strong intermolecular force. They have strong intermolecular force. So this is the basic thing we need. Okay. So students, along with that, they have definite mass, volume, as well as shape. Correct? Solids have definite mass, definite volume, and definite shape. Understand? At the same time, they are very tightly bounded. The nuclear distance, intermolecular distance is very small, and the intermolecular force is strong. So now you compare this gas. So here the distance is very low. So here large intermolecular distance is there. Large intermolecular distance. Next, if the distance is more, the attraction force between these two atoms is very less. So here it is weak intermolecular force. Okay, so here gases has only mass, not shape, not volume. Sorry, they have only mass, not volume, not shape. Okay, the shape depends upon where the gases are placed. And the volume depends upon, like one volume, two volume means that is also depends upon the anti-gas. Okay, here also. If we consider solid is like this, gaseous is like this, means the properties of the liquid in between solid and the liquid. That means it has comparatively less intermolecular force with respect to solid, comparatively more intermolecular force compared to gases. That is in between solids and liquids. So we can easily say small comparatively large intermolecular distance and weak intermolecular force with respect to solids. Okay, so consider only with respect to solids. They have large intermolecular distance and weak intermolecular force with respect to solids. Okay, next, here solid has mass, volume as well as shape. Here it has only mass and volume but not shape, because shape of the liquid is changed according to the container or the species where it present. Okay, the substance where it present, it occupies the shape of that substance. Understand? If it is in a tank, it occupies the shape of a tank. If it is in a bottle, it occupies the shape of a bottle, like that. Okay, gas is also same. If gas is present in a balloon, it occupies the shape of a balloon. Okay, if it is present in a square cube, then it occupies the shape of a cube. So this is the properties of solids, liquids and gases. Okay, so in this chapter we are going to study the liquid as well as gas. First we will study gas, later liquid. Understand? So this is the physical classification of the matters. So students, before that, I'll explain different forces which are present in atoms. Which type of forces are present in between the molecules and in between the atoms. Okay, students, listen here. First I'll write, covalent bond is there. It is a strong one. Okay, and also ionic bond is there. It is comparatively weak bond. And also metallic bond is there. So that is in between ionic bond as well as covalent bond. Similarly, van der Waals force is there. That van der Waals force tells about different bonds. So that van der Waals force is existing in liquids and gases. Why it is van der Waals force? Because it is not exactly the bond formation between the molecules. It is just an attraction force between two atoms. It is not exactly a bond formation, because listen, here I will take atoms. Helium is there, both are noble gases. Gas is there. So they are far away from each other. So students, here, helium is there means in the nucleus, proton is there. Our nucleus is a positive charge because protons are there. Neutrons are zero in charge, you know that. Okay? So electrons are there. Electrons are negative in charge. This is one helium atom. So here another helium atom I take. Here also nucleus is positive charge and this one is negative charge. So students, if these two atoms are neighboring to each other, because they are gases, they are not exactly adjacent, they are just placed neighbor to each other. Okay? So here the plus charge is the nucleus. It has an attractive force between these two electron of the same atom, and at the same time when they comes closer, understand, this nucleus also attract the electron from this atom. Similarly, this nucleus attract the electron from this atom. There is a force of attraction exists in between the nucleus of the one atom and electron of the other atom. Understand? So at that time what happens? There is no bond formation because they are gases, they cannot form, they are in a stable configuration, they do not form a diatomic molecule. They won't form any bond. But there is a force of attraction. So this is very weak. If they are very close to each other, then the attraction is there. If they move apart, the attraction disappears and a repulsion takes place. Okay? So this is what called as van der Waals force. This is one example. A weak attractive force exists in between two atoms. That is called van der Waals force. It is not a bond, it is just a force of attraction. Okay? So this type of van der Waals force are three types. One is dispersion or London force. So type of van der Waals force are there. One is dispersion or London force. Another one is dipole interaction. Third one is dipole induced dipole. Dipole induced dipole. And the last one is hydrogen bond. Last one is hydrogen bond. Okay, except bonds I am telling. It is just a force of attraction between the two molecules of a gas or a liquid. Okay, in solid there is a bond. Understand, students? So I will explain what is dispersion force or a London force, dipole induced dipole, and also hydrogen bond one by one. So listen here. Here. So dispersion or a London force is existing homo diatomic molecules. Homo diatomic molecules. Homo means same. Diatomic means two atoms. For example, here N2 is there, H2 is there, O2 is there. Next. Halogens, F2, Cl2, etc. Diatomic molecules they should be, and their homo means same atoms. Okay. So students, I will consider hydrogen here. So hydrogen, two atoms are there means here also electronic configuration 1 is 1, here also electronic configuration 1 is 1. Number of electron is 1, number of proton is also 1, number of neutron is 0 in both the cases. And in both the oxidation state exhibit +1 or -1. If they are in the presence of, if they behaves like a halogen, that is -1. If they behaves like a alkali metals, then it is +1. It is one of the different property of hydrogen. That's why, as I told you, the alkali metals are considered from lithium to francium. I didn't involve hydrogen, right? Why? Because hydrogen shows the property of as well as alkali metals as well as halogen. So they can exhibit +1 as well as -1 oxidation state. In the hydrogen chapter, I will explain. Okay, that is anomalous, means different behavior of a hydrogen. So all the properties of these density is there, same charge is same, electrons are same, everything same. So but then also there is a bond between this hydrogen atom. Correct? So hydrogen atom is a diatomic molecule. So in the containers, if you consider hydrogen means, so hydrogen will be like this. One H2 molecule together present in the atoms. Understand? In between this hydrogen, covalent bond is there. But we don't bother about the covalent bond because one hydrogen atom exists as H2. Okay, that means it is in this form. It is H2, 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 H2 like that. Understand? So it is already bonded. So now what happens, students? Listen. Here I write hydrogen is the hydrogen with their electrons plus Plus minus is there, assume. One proton is there, one electron is there, assume only electron, minus only. Because protons we don't bother about it, electrons are the main reason for the attractive force and the repulsive force. So students, here, both the hydrogen, as I told you, they have the same charge and the same polarizability. That means it never gets plus, it never gets minus. Understand? Like HCl, we'll write like H plus and Cl minus, right? Like this, here it cannot be possible because their attractive force and the electronegative value is same. This hydrogen cannot attract the shared pair of electron of this hydrogen towards itself because how much of this possesses the electronegativity, same electronegativity is possessed by this atom also. So we cannot separate the polarized charge. But students, when the another atom of hydrogen approaches them, another molecule of H2 is approaches towards H2. Then there is an attraction and repulsion force. As I told you, here helium is there. Instead of helium, I take hydrogen. Here one proton is there, that is plus charge, and electron is there, that is minus charge. When they come close to each other, they experience a force. That's what I told before by taking example of helium. Understand? When they come closer, they exert or they experiences some attractive force. Then what happens? One can get plus charge, another can get minus charge. Understand? For example, if I write here, two hydrogen molecules are there. This one hydrogen is here, another hydrogen is here. When another molecule of hydrogen come closer to this, understand? Among these two, one can experience a minus charge, another can experience a plus charge because of the attraction force between the nucleus of these two atoms. Understand? So then what? There is a force of attraction exists in between the molecules of H2. So this force is called as dispersion or London force. Why it is called as London force means because the scientist named as London discovered this type of force, that's why this is called as London force. Understand? The scientist name ends with London, that's why this is called as a London force. And dispersion means, of course, if we move apart these molecules means the force will disappear. Understood? So this is a dispersion force or a London force. Means these two are non-polar molecules. Polar means opposite ends, you know. North pole, south pole. In the magnetic, the opposite poles are called as poles. So here polarity also means plus and minus charge. Okay? Non-polar means they don't possess the plus and minus charge. So if the force of attraction exists between a non-polar molecules, then it is called as dispersion or London force. Understand? Force exists between what? Non-polar molecules. Here, another one you heard about the word non-polar molecules. Very important thing, students, because based on this, they'll ask one mark question. For example, H2, they'll give what is the force of attraction is present in the H2 molecule. They may ask H2 molecules. Then you have to write London or a dispersion force. Understood? So the next one is dipole. Next one is dipole. Example is HCl. Students, I will consider two HCl molecules, HCl, and here it is HCl. Correct? Here in this there is no doubt this one will get plus charge, this one will get minus charge. Here also this one will get plus charge, this one will get minus charge. So students, this type of force, H is there, Cl is there. The electrons are moving towards this type. The electron density is shown by this type of direction. That means the electrons are moved towards hydrogen to chlorine, chloride. Understand? So this is the direction or a symbol to represent dipole. Dipole tells about what? This end tells about the negative charge, where the electron density is more. This one tells about where the electron density is less. So students here, both are in this direction. Correct? So both the atoms can have the dipole moment. So this one is also called as, because it has plus and minus. Both the polarizing powers are there. That's why it is called as dipole, both the plus and minus. Dipole means different charges, plus and minus. So though this one is also dipole, this one is also a dipole. Okay, if there is a force of attraction between this Cl atom and this plus atom. Okay, instead of this, if reverse is there, here Cl is there, hydrogen is there, Cl is there is a force of attraction between this hydrogen and this Cl. This is also a dipole interaction. For example, students, here in a gaseous form, we are considering what? HCl here. The force of attraction between these two is the dipole-dipole interaction. Why? Because both the molecules possess permanent dipole. Understand? Why they possess permanent dipole? They are non-polar molecules. Polar molecules means they possess plus as well as minus charge. Because they possess polarity. Because of these polar molecules, they possess permanent dipole. So both the atoms have a dipole means the force of attraction existing between them is a dipole-dipole interaction. Just by so considering the nature, initially both are non-polar. Polarity is 0. So the force exists in between is very less. So that's why this is called as dispersional dipole. Here both the molecules are polar. Both have dipole moment. So this is also dipole, this is also dipole. The interaction is dipole-dipole interaction. Understand? Okay. So here you can easily say, students, this dipole moment is exhibited by polar molecules. And listen, whether this is homo or hetero, homo means same. So this one is hetero. So this one is exhibited in hetero diatomic molecules. It is not like only diatomic. Simply I am telling you. Okay? It may be a triatomic, tetraatomic, we don't bother about. Okay? It must be heteroatom, different atoms. And the example for this is HCl, H2S, etc. Understand? So I will write the chart, students. First you understand what is the force and how it experiences by the molecules. Okay. The next one is dipole and induced dipole. Another one is dipole and induced dipole. How it explains? So listen. Dipole means, of course, we have to consider. I'll take HCl only. Okay, it is a polar molecule. It is called as a dipole. What is induced dipole means? So students, initially you consider helium atom. Are a non-polar, not only helium, you may consider hydrogen, fluorine, oxygen, any monoatomic. So here it is a polar molecule. Here it is non-polar. I'll write H2 only. Non-polar. Okay. Here dipole moment is towards this direction. Here there is no dipole moment. Understand? When they come close to each other. When they come nearer to each other. Okay, here it is X, here it is here, dipole moment is towards this, then this is minus charge to minus, this is plus, correct? So this is minus charge, means this will attract the plus charge species. So this become plus means obviously this will get minus charge. Understand? So because of the presence of RF, because of this molecule, the dipole molecule, this also experiences a dipole moment. Here, the dipole is not present. Because of this molecule induce a dipole character to this. Understand? So this dipole moment or a dipole character is exhibited by the presence of this molecule. So this one is a dipole. This one is induced dipole. Understand? So this interaction is induced dipole and induced dipole interaction. Understand how it is? When the polar molecule is there, non-polar molecule is there. Polar molecule has permanent dipole and this non-polar molecule is zero dipole moment. That is zero dipole. Understand? So when they come close to each other, because of this permanent dipole molecule, it induces a dipole moment to the respective molecule, non-polar molecule. So because of the presence of this, or a force of attraction between this, or nature of this, they exhibit a polarity. Okay? So here, from non-polar to it become polar. From zero dipole moment to it become a dipole molecule. Understand? So this is induced by this molecule. So that's why this is dipole induced dipole interaction. Okay. So here this type of interaction is exhibited in polar and non-polar molecules. Okay. You may take HCl and helium, HCl and noble gases, HCl and H2, HCl and O2, any non-monopolar and with polar. I am not telling only HCl, you may take HF, HBr, HI, H2S, anything. Understand? So the next one is hydrogen bond. So hydrogen bond is purely a bond between hydrogen and the other atoms. Okay? Next. Students, I will take two examples here. This is the benzene ring. Here hydrogen is there. Here N double bond O is there. That is NO2. Benzene ring means C6H6, you know. It is like this. Correct? So one hydrogen is replaced by NO2 molecule. So this is the structure of this. I wrote this in this expanded form. Okay. This is one type, students. Another one I consider H2O. ISIM I consider. Okay. So what is hydrogen bond means? The force of attraction between hydrogen and highly electronegative atom. Understand? The force of attraction between hydrogen and highly electronegative atom means especially nonmetals. It may be nitrogen, oxygen, fluorine, any halogens. That understand? Between hydrogen and the highly electronegative atom. So students, here this is already a covalent bond. We don't bother about it. What is this hydrogen bond means? Here within the molecule, hydrogen is also there, oxygen is also there. It is a electropositive, it is a electronegative. There is a force of attraction between these two, hydrogen and a highly electronegative atom. So here in H2O, hydrogen, oxygen is also there, hydrogen is also there, they are bonded. We don't bother about them. But the way the hydrogen bond will exist in between the hydrogen of one atom and the electronegative atom of the other atom. Here oxygen is there, here hydrogen. Here oxygen is there, Here hydrogen. So here hydrogen. And here hydrogen is there, this is with oxygen. Understand? The hydrogen atom of the one water molecule with the electronegative atom oxygen of the other water molecule. So this type of bond is called as hydrogen bond. So why I take these two examples means, so listen, here completely water is a one molecule. Correct? If the hydrogen bond takes place in between two atoms, this is intermolecular hydrogen bond. Intermolecular hydrogen bond. If it is takes place within the same molecule, then it is intramolecular. Intramolecular hydrogen bond. Understand? Within the same molecular, intramolecular hydrogen bond. So, in between two, then it is intermolecular hydrogen bond. Understand? So, this is hydrogen bond students. If this hydrogen only exists between hydrogen and highly electronegative atoms. It may be oxygen, nitrogen, chlorine, etc. Understand? So these are all the four different types of van der Waals force which we are going to exhibit. So which we are going to observe in the gaseous molecules. Understand? Gaseous as well as liquid. Understand students? So total four are there. Dispersion and London, dipole-induced dipole, hydrogen bond, etc. So in all these, hydrogen bond is very strong. All these four van der Waals force, the hydrogen bond is the strong bond. And they may ask the question, what is the reason for, if you know, oil is insoluble in water, sugar is soluble in water, correct? Salt is soluble in water, but not oil. Why? Because in the oil are the long chain fatty acids. Okay, there is no free hydrogen. If any hydrogen is there, oxygen is there, then only they can form, water can form a hydrogen bond with other molecules. Understand? If the hydrogen bond formation takes place, then only any molecule is dissolved in water. If there is no hydrogen bond, then it cannot be dissolved in water. Understand? What is the reason for solubility means? Because there is a formation of hydrogen bond with water. If any atom or a species, solute what we are adding, if it has the capacity to form a hydrogen bond with the water, then it is soluble. If anything is insoluble means there is no free hydrogen, there is no formation of a hydrogen. That is important for one to remember. What is the reason for hydrogen bond? Not in this chapter, in the hydrogen chapter. Okay, but it will important for marks, whether it came from here or there. Marks is marks now. Okay, next. So this is all the van der Waals forces. So I'll explain once again. So this portion and the London force means the force of attraction exists in between non-polar molecules. Okay, the force of attraction exists between non-polar molecule is called as dispersion or London force. The example for that is N2H2 O2, etc. Homoatomic molecules. Next, the force of attraction between the polar molecules is called as dipole-dipole interaction. Understand? Example is HCl, H2SN, etc. Next, what is dipole-induced dipole? The force of attraction exists between the polar and non-polar molecule. Example, you may take HCl and helium or HF and H2. Okay, one is polar, another one is non-polar. Next, hydrogen bond is the force of attraction exists between hydrogen and a highly electronegative atom. That is called as hydrogen bond. In that hydrogen bond, two types is there. One is intramolecular, another one is intermolecular. If the hydrogen bond takes place within the molecule, within the same molecule, then it is intra. Understand? Within the molecule means electron. If the hydrogen bond takes place in between the molecules, that is intermolecular hydrogen bond. Understand, students? So this is all about the forces. So in the next class, we will discuss about the gaseous state and their properties. What happens if thermal energy is there? Another one I will explain, students. You know what is the relation between this thermal energy as well as this force of attraction? If we add temperature, increase temperature, if we decrease temperature, what happens? Okay, I will explain that in the next class. Remember another one. So these forces are inversely proportional to distance between them. If distance is more, force is less. If distance is less, force is more. Correct? So these forces are inversely proportional to distance. Distance between the two atoms is r. Radius is. Okay, distance r you may take it as d. So d is nothing but is equal to r. So students, here how much it is equal means it is equal to 1 by r to the power of 6 times. Dispersion force is equal to 1 divided by r to the power 6 times. Okay, that much of very less interaction is there. Okay, here also it is in this students here stationary is there. Stationary means the stable at their position. Another one is revolving around other. So if the stationary is there, that is 1 by r cube. If rotation is there, then it is 1 divided by r to the power 6. This is also 1 divided by r to the power 6. This is also 1 divided by r to the power of 6. Only the change is here. In the dipole dipole, if they are stable, stationary, they fixed at their position, then it is 1 by r cube. If they are in the rotation mode, okay, then they are 1 divided by r to the power 6. That is the relation. Distance and the force. If the force is less, distance is. If the force is more, distance is less. They are inversely proportional, you know that. Okay. So this is all about the water transport. In the tomorrow's class, I'll explain the thermal energy effect on this, different forces, the gaseous molecule and gaseous glass. Okay, thank you.